This video covers section 6.4, Volcanism reveals a geologically active planet. Four processes have shaped the terrestrial worlds: impact cratering, tectonism, volcanism, and erosion. Volcanism is the occurrence of volcanic activity on the planet or a moon. Volcanism is indeed related to tectonism. Most of the world's volcanoes lie along plate boundaries. This is because of the tremendous friction generated by the plates, which provides heat to the lower crust and upper mantle. Heat from convection cells then adds to that, producing the molten material needed for a volcano. Each triangle on this map marks a volcano, and notice how almost all of them lie up with the plate boundaries. Volcanoes are not restricted to lie along plate boundaries. They can also form on hot spots in the crust, where molten material can make its way to the surface. Known as shield volcanoes, the cover of a very large area but a relatively low profile. They are made almost exclusively of mantle magma and have very fluid consistency, which means they spread out more before it hardens. Composite volcanoes are conical volcanoes built up of many layers or strata of hardened lava, tephra, pumice, and volcanic ash. The lava is thicker and doesn't spread as far. Unlike shield volcanoes, composite volcanoes are characterized by a steep profile and periodic explosive eruptions. Composite volcanoes are usually found above subduction zones. Hawaii is made of volcanic islands that are not on a plate boundary. They are in the middle of the Pacific Plate. The question is, how did they form? The Hawaiian chain is a string of Pacific islands over 5,000 kilometers long. Using radiometric dating, the age of the rocks of the Hawaiian chain can be found. The oldest islands are farthest from Kilauea. Age is related to the Pacific Plate motion. Kilauea is also the largest island. The older the island, the smaller because of erosion. The oldest of the islands are undersea mountains. Convection is the underlying mantle produced hotspots, and that the islands arose from magma poking through the seafloor as the plate moved over the hotspot, stretching both to the west and to the north of Hawaii. There is a string of smaller islands and submerged volcanoes about 3,700 miles long. Each of these islands are seamounts, a volcano mountain found below sea level, is said to have formed in the location of Hawaii presently is. A hotspot formation produces a large shield volcano. Plate motion causes the volcano created above the hotspot to slowly drift away from the hotspot. This creates new islands, and the chain points in the direction of the motion of the plate. Erosion slowly destroys the oldest islands. The Hawaiian Islands are a direct product of hotspots. Off the southeast coast of Hawaii, a new volcanic island is forming. It will be the newest member of the Hawaiian chain when it breaks through the surface. Still 3,000 feet below the sea level but growing, the new island will be named Loihi, meaning long in Hawaiian. Lava is hot, fluid, molten rock that flows along the land surface. Lava can flow like a viscous water, forming lava rivers and lava falls. Pahoehoe in Hawaii is lava with a rope-like structure and surface temperature due to partial cooling as the lava flowed. It is relatively hot, low viscosity lava. Volcanoes exist on all four terrestrial planets, though primarily on Venus, Earth, and Mars. The Moon and Mercury currently appear to be inactive, but have ancient extinct volcanoes. Earth has active volcanoes. Venus has recent volcanoes, and Mars has old volcanoes and appears to be currently inactive. The moon had past lava flows which smoothed out parts of its surface, the maria. These do not have to come from volcanoes, but could come directly from cracks in the crust. We see no volcanoes on the moon, although the Lunar Reconnaissance Orbiter has spotted a few interesting formations that could be inactive volcanoes. Mercury has smooth surfaces from past volcanism, and a few inactive volcanoes have been identified. Mercury is currently inactive, which is not a surprise since they are small. And in 1974, the spacecraft Mariner 10 sent the first close-up pictures of Mercury, revealing vast, smooth plains near the planet's north pole. Such smooth fields are thought to have been created by flowing lava on the moon and on the Earth. However, the Mariner data from Mercury was inconclusive since Mercury's plains were the same brightness as the planet's highlands, while on the moon the volcanic deposits are significantly darker. No volcanoes were identified in the Mariner data. The Messenger mission solved the mystery in 2011, finding evidence of fissure vents, hugely long cracks in Mercury's surface from which lava could have flowed. Venus shows no current volcanic activity, but has had recent volcanoes. Dominated by volcanic activity, the surface of Venus has more volcanoes than any other planet in the solar system. The composition of the surface is 90% basalt and about 65% of a mosaic of volcanic lava plains. Based on the density of impact craters, more than 1,000 volcanic structures and possibly periodic resurfacing of Venus by floods of lava appear to possibly have had a major global resurfacing event about 500 million years ago. Venus has a carbon dioxide rich atmosphere with a density that is more than 90 times greater than Earth's. Even though there are over 1,600 major volcanoes on Venus, none are known to be erupting presently, and most are probably ancient and extinct. However, radar sounding by the Magellan probe reveals evidence for comparatively recent volcanic activity at Venus's highest volcano, Mons, in the form of ash flow near the summit on the northern flank. The search for ongoing volcanic activity in the vicinity of Mons is currently being investigated. A pancake dome, also known as a lava dome, is a type of volcano that so far appears to be unique to Venus. Pancake domes have a broad, flat profile similar to shield volcanoes. The surfaces are covered with patterns of small cracks and faults, and they usually have a central pit or bowl-like feature similar to a volcanic crater. It is thought that these pits form after the eruption of the lava cools and emits gas rather than being a vent from which the lava originated. Mars has old volcanoes. On Mars, the slopes of some volcanoes have a few craters. Mars has the largest volcano in the solar system, Olympus Mons. The shield volcanoes on Mars are the largest mountains in the solar system. Olympus Mons is a very large shield volcano on the planet Mars. It has a height of nearly 22 kilometers. It is the youngest of the large volcanoes on Mars, having formed during Mars' Hesperian period. Roughly the size of France, it is currently the largest volcano in the discovered solar system. A cryovolcano, or ice volcano, involves eruptions of volatiles, water, ammonia, methane, etc. These substances are liquids or vapors and can form plumes. After eruption, cryomagma condenses, forming a solid. Cryovolcanoes are found on Mars and some moons of gas giant planets such as Europa, Titan, Ganymede, and Miranda, and on some dwarf planets like Pluto and Ceres. Hawaiian basalts are similar to the surface composition of Mars, Mercury, and Earth's moon, which were formed by ancient volcanic processes. Of these, only Earth appears to remain volcanically active. There is no evidence of recent volcanic activity on Mars, Mercury, or Earth's moon. Venus's surface is dominated by volcanic features which include shield domes similar to other planets and unique pancake domes. Venus may still be volcanically active, but this has not been confirmed.